Balancing chemical equations. What is a chemical equation? A chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulas wherein the reactant entities are given on the left-hand side and the product entities on the right-hand side. These are the parts of an equation. On the left side of the arrow, you can see the reactants. On the right side, you have the products. And the arrow is a reaction symbol, which means turns into or yields. Let's get to know more about reactants and products. The substances you have at the beginning are called the reactants. The new substances formed at the end of the reaction are called the products. The formulas for the reactants are written on the left side of the equation. The formulas of the products are written on the right side of equation. Subscripts and coefficients. Notice that the number of atoms of each type is obtained by multiplying the coefficient and the subscript associated with each element in the formula. When you say subscript, it shows how many atoms of an element are in a molecule. Example, we have the molecule water or H2O. As you can see, there is a subscript 2 here in hydrogen atom. It means that it has 2 atoms of hydrogen. And as you can see here in oxygen, it has no subscript, and it means that it is 1 atom of oxygen. For coefficient, it shows how many molecules there are of a particular chemical. For example, you have 3H2O. The coefficient 3 here in water means there are 3 water molecules. Let's have an example of a chemical reaction. We have 2H2 plus O2, which yields 2H2O. As you can see in the illustration, there are 2 molecules of hydrogen gas react with oxygen gas, which yields 2 water molecules. In balancing equation, law of conservation of mass is very important. The law of conservation of mass states that mass in an isolated system is neither created nor destroyed by chemical reaction or physical transformation. In a chemical reaction, matter is neither created nor destroyed. In other words, the number and type of atoms going into a reaction must be the same as the number and type of atoms coming out. If an equation obeys the law of conservation, it is balanced. Let us have an example of an unbalanced equation. CH4 plus O2, which yields CO2 plus H2O. As we can see on the reactant side, we have 1 carbon atom, 4 hydrogen atoms, 2 oxygen atoms. On the product side, we have 1 carbon atom, 2 hydrogen atoms, and 2 plus 1 equals 3 oxygen atoms. If we will check the atoms individually, for carbon, on the reactant side 1, on the product side 1, it's balanced. For hydrogen, on the reactant side we have 4, on the product side we have 2, it's not balanced. And on the reactant side for oxygen we have 2, on the right hand side it's 3. So this is an example of unbalanced equation. An unbalanced equation means that there are unequal numbers of at least 1 atom on each side of the arrow. The chemical equation needs to be balanced so that it follows the law of conservation of mass. A balanced chemical equation occurs when the number of the different atoms of elements in the reactant side is equal to that of the product side. Balancing chemical equations is a process of trial and error. If we are going to balance this equation, the result will be this. Let me show you the process of trial and error. This is the unbalanced equation earlier. First, you list all the elements in the chemical equation. On the left side, or on the reactant side, we have carbon, hydrogen, and oxygen. And of course, on the right-hand side, we also have carbon, hydrogen, and oxygen. So you are going to list this identically. And then you identify the number of atoms. For carbon, it has 1 atom. For hydrogen, it has 4 atoms. For oxygen, it has 2 atoms for the reactant side. For the product side, we have carbon, 1 atom, hydrogen, 2 atoms, oxygen, 2 plus 1 equals 3 atoms. Notice on the list of elements, for carbon, it is already balanced. For hydrogen, it's unbalanced, and for oxygen, it's unbalanced. We will have trial and error. We will try to write 2 here as coefficient of O2. So 2 times 2 equals 4 atoms. Now, on the right hand, it's 3 atoms. On the left hand, it's 4 atoms. Next step, we will try to write another 2 here for water as coefficient of water. So, 2 for hydrogen, 2 times 2 equals 4 atoms. And for oxygen, we have 2 times 1 equals 2 plus 2 is equal to 4. Okay, we will check. Is carbon balanced? Yes. Is hydrogen balanced? Yes. And is oxygen balanced? Yes. Remember the rules of the game in balancing equation. First, matter cannot be created nor destroyed. Subscripts cannot be added, removed, or changed. You can only change coefficients. Coefficients can only go in front of chemical formulas, never in the middle of a formula. A few extra tips. Try balancing big formulas first. Save free elements for last. If the same polar atomic ion appears on both sides of the equation, it's usually okay to treat it as one unit. There is no one particular way to balance equations. Some equations are harder to balance than others and might require some creativity to solve. Let's have another equation. N2 plus H2, which yields NH3. As you list the elements, nitrogen, hydrogen. On the reactant side, you have 2 atoms of nitrogen, 2 atoms of hydrogen. On the other product side, you have 1 atom of nitrogen and 3 atoms of hydrogen. Notice that they are not equal in the number of atoms. Let's try to place 3 here as coefficient of H2. So hydrogen now will become 2 times 3 equals 6 atoms. 6, and on the product side it's 3. So what are we going to do? Maybe we could place 2 here as coefficient of NH3. So 1 times 2 is equal to 2 atoms. 3 times 2 is equal to 6 atoms. If you will check, nitrogen has 2 atoms both on the reactant and product side, and hydrogen has 6 atoms both on the reactant and product side. Our equation is now balanced. Your turn. Balance the following equations. Remember, it is important to balance chemical equations because equations represent real-world chemical reactions. This becomes important when we calculate stoichiometry equations where mole ratios become significant.